So hello everyone and welcome to this next lecture on Python Power Electronics, and in this lecture I'm going to start, or rather lecture series, I'm going to start with how to design actual control functions. So as I said before, in Python Power Electronics you can write your own control functions, and I'll start with the other example, that is with the diode rectifier feeding a load, and one of the load has a switch in series. So we are now going to try to control that switch. So I'm going to break this lecture up into several parts because there are several parts to control, and I'm going to talk about each and every one of them in detail so that you have an idea of what exactly the control is. So to begin with, let me run over to my web browser and let me go to the project website, this pythonpowerelectronics.com. And in this, before you start with this video, I would suggest go over to this part. So this is the home page. This is the first section, that's tutorials downloads, and then there is the other section. The second part of the second section is only downloads. So here there is one which is software. This is where you actually get the software version. We don't need it now because I already have installed it, and if you need to install it, go to the previous lecture and see how that is to be done. In this you need to go to this link, papers. Okay, so I'm going to click on this. Now I have written a number of papers on the circuit simulator and on control and even some other aspects of it. So for this particular lecture and in general for control, there are two papers which are relevant. The first one is this one called control structure. Okay, and this is a short paper on the special variables available for user-defined control functions and how they can be used in control functions. So I'm going to open this, and this is basically a short paper which I wrote about how control is to be designed. So like for example, this just shows, let's say this is a different control files, how it actually is implemented in the simulator, and then things like, for example, there are some special variables. So what are those special variables? So this is a list of the special variables. So at this point of time, what I would say is, so this is a list of all the special variables. So what I would suggest is pause this video right now, go over to this link and read this paper. Alright, because this paper tells you about all the different aspects of special variables and why they are needed in the control, why they are needed for this simulator. And the other paper is this one, and that's the next one. It's called timing scheduler, and this is a short paper on how the circuit simulator times, schedules actually, or rather coordinates the timing of when the control functions are executed. Alright, so this is a slightly advanced paper, and if you don't want to read it now, that's okay, though I would suggest that you should read it at some point of time. So like for example, here this one tells you about how the different, just go a little further, like for example, this gives you one example and it tells you how the simulator execute this entire concept. For example, what is a time event and things like that. So this is a very detailed explanation of it. You don't read it right now, but I would suggest that at some point of time try to do it, because this will help you, especially in the later lectures when we are talking about control timing and timing event variables. This will be very useful. So, but most importantly, please do go and read this paper called control structure. That is structure of user-defined control functions, and the name of it is control structure.pdf. So before you continue with this video, pause this video right now, read this paper, and then continue only when you've read it. So if you're continuing now, I'm assuming you've read it. So let me again open this anyway. So I am going to go through this paper. You don't have to, but I'll just tell you where different parts are. And in order to run this, I'm going to do it with an example. So let me go over to my web browser, or rather let me start off my simulator. Let me go into my folder, virtual environment. So this is the entire folder where I've been using for all my different applications. So to begin with, let me start with the virtual environment. So you see, now I have activated my virtual environment. So now I'm in Python 2 test. As usual, just do a check, make sure the Python 2.7. And now that this is done, the next part is we go into PP web app. So now I have to start off my simulator. As before, if you need to know how this is done and how you set it up, please go to the previous lectures and check it out. In those lectures, I've described how you install the circuit simulator, how you set up the circuit simulator, everything else. If everything is set up, all you have to do is launch the server by running this command python manage.py run server. So the server is running, it is running at this particular link. So I'm just going to go over to my web browser, the same web browser. I'm using Google Chrome, and yeah, the address is already stored. It's 127.0.0.1:8000, and I have the simulation. So I'm going to continue with the simulation which we created before, that is diode rectifier with switch load. So I'm going to just load this simulation, and you see this is all the stuff which I saved before. I don't have to change it, so I'm just going to save it. Back to main page. Let me check out circuit files. So these are the circuit files, the same 3 circuit files. If you need to know what these are, please go to the previous lectures. There is a source file, there is a diode rectifier file, and there is a load file. I don't need any more than this. So let's again process, because remember, you always have to process the circuit schematics every time you start this. So let's run this. The circuits do not have any detectable errors because this is where we left the circuit at. It's working. Let's go back to the main page. Edit circuit simulators. So in this there are all these different components. We don't really need to change anything, except I'll just show you where it is. We had this switch load 2, it's called name load 2 with a control tag of switch load 2. This is what we are going to now control in this. We're going to start controlling in this lecture series. Okay, so there's no need to edit it, we can leave it as it is. You can go back, and now we have everything. So until now we didn't do any control, we had not included any user control in this simulation. So we would actually skip this and we would go straight to the output. Alright, because you can just run this file. You can just run this file and plot these two files. Now what we're going to do, we're going to actually start with the control. So let me go click this button. So the first thing is you got to choose a control file. So let me just choose a control file. For that, let's go over to our Atom and let me add the project folder. So the project folder is virtual environment. Let me add it. We got all of it. Now I am in this file called diode rectifier. Alright, so inside diode rectifier I am now going to start with control. So what I need is I need to create a control file. A control file is a Python file. So let me just start off by saying new file. Okay, and I'll create this file. Let me just call it, what do I call it? I say switch control.py. Name it anything you want, not a problem. So now we have this control file. Great. So now that we have this, let's go add it here. So you see switch control.py, and we open it. Let's put a little description. Let's say we're going to start, let's say design a control for the switched load. Alright, just anything. This is just control description just for you to know what it is doing. When you have a lot of control files, it'll be nice to have a short description. So let me save this. And then again, as usual, you must save it. If you just add it, that's not good enough. If you don't want it, if you think you made a mistake, you can click on this remove control. So for example, I can just click on this again and add it again. That's up to you. Alright. And remember, you cannot continue by just clicking add control file. You will lose this. If you want this to be added to the simulation, you must click save control file. And only when this appears, you know it has been added to the simulation. Alright. So now that we're done, we are not totally done yet, because all we've done is we have added a control file, and this control file is an empty file. But that's not what's important. What's important, we need to configure the control. If you've used any other simulator, like you've used several other commercial simulators, usually what happens is the control file is like a little block, and this block will have inputs and outputs. All right, you can add input ports, you can add output ports, and in the same way we have to do the same with this one, and that's how we have to go into configure control. So let me click on configure control. So you see these are all the different parts of it. Now if you want to know the details, go over here and you'll see these are all the ones which I've described. See, inputs, outputs, stored variables, global execution instance, global variables. And if you look, these are exactly the ones: input, output, static variables, variable storage, time event. And if you come here, you'll see it's exactly the same: control inputs, control outputs, static variables, time event variables, variable storage. So we'll go with this gradually, bit by bit. All right, now the best part is, unless you give an output signal to the switch, it's not going to regulate anything. The switch remains open. So we can take advantage of that fact and add all these bits, all these outputs bit by bit, and leave this control output for the end. So this way I can show you every aspect of this controller and leave the control output till the end when I know we have the control that we want. Alright, so this is a technique I'm going to show you. So let's start with control inputs. It's pretty obvious, the name. Control input is any input to the control file. Now in this simulator, when you design a control input, that control input has to be a measured variable. Okay, it cannot be any variable, it has to be a measured variable, which means it has to be the measured output of either an ammeter or a voltmeter, because at the time of making this video there are only two meters in this simulator, ammeter and voltmeter, and these are the two meters that can produce a measured output. So what would be, let's say for example we add both of them, let's say we add some. So you see here, this says these are the list of control inputs in the file. Alright, you can add them and we can delete them. So I'll show you everything bit by bit. So the first part is, this is one particular control variable. You see what it says: desired variable name and control code. What this means is, we are connecting an input to the controller, and this input can be made available in any variable you choose. Okay, so if I choose some variable saying XYZ, whatever I choose here, the input source, let's say ammeter source 1, let me go over and open this file. Diode rectifier, and ammeter source 1 is probably in source, so let me go over and open it. So let me see where it is, and this, yeah, so this is the ammeter source 1. This measures the current produced by the single phase voltage source. So if I want to measure this current produced by the single phase voltage source, and if I want to add it into the control variable, I can use any variable here. Alright, the simulator will copy the measured output of this meter and plug it into the control variable by this name, and I'm going to show you how that happens. But this is what it means. It means I can specify any variable here and I can just use it directly in the control function. So let's see how that happens. So let's say I have XYZ. Now let's call it something nice. Let's say I say iSource1. Now once after choosing this, you have to click save input. Okay, so now this has been added. If you don't want it, you can delete it. Now let's add another one. Let's add voltage source 1. So let's call this V source 1. Alright. Now as before, save input. So now you see we have two, and in this manner we can just add as many as you want. Now you see here the drop down list shows you all possible meters that are there in this circuit. So technically speaking, if there are, let's say 100 meters, you would have a drop down list of 100 meters. Now when circuits do get complicated, it may be a little tough to find your meter, and I'll see if I can make it a little easier to do it. So let's also add voltmeter V output. Okay, and let's call this V out 1. So with this, I have created 3 inputs and I am now feeding it to my control file. Let's say for example, for instance, I stop here, because like I said, I'm doing this bit by bit. So we put in a control input. Let me see what happens now when you add this control input. So let's just say we are done here. When you're done doing all this, you got to come here and click on this button, back to control main. All right. So this means you're done with the control editing. So let's click on back to controlling, and this is, we are back to this main control page. Now it shows you this dialog box because that's the default. As I said before, until you click on this save control file, nothing happens. So if it is like this, you don't have to worry. So don't worry that, oh, there's an empty dialog box, what do I do with it? It doesn't matter. Until you click save control file, this is not added to the simulation. So this is just a dummy box. So for now, let's click on back to main page. We've added one control file. Let's view this output. So you might think this is a little strange, and it is, because I have an empty control file. There is nothing in it, switch control.py. I have added 3 control inputs and I'm doing nothing with them. Alright, it seems strange, but I'll tell you what exactly I'm trying to do. Let me run this simulation. Okay, simulation is running. Just for the safety's sake, let me go once to my command line, and you see it is okay. If there was an error, it would have popped up. There's no error, so it's okay. Now there is something else which you need to see. Now if you come to this file, or rather this is my web browser, and if you read this file, this tells you how these control files are actually entered into the main file. Now I have taken 2 control files, and you can add as many as you want. All these control files, whatever you've chosen, in my case it's switch control.py, these are added into a file called __ control.py. Okay, so this is a reserved name. Do not name any of your control files as __ control.py. Okay, this is a file which the circuit simulator creates, and in this circuit file it will create a number of functions. It will create a function for every control file that you create. So every control file that you create, the code inside that is going to be plugged into this function, and it is these functions which are executed from within the circuit simulator. That's how it works. Okay, for more details, read this document just to give you an idea what's happening, because the next start is I'm going to go and show you what happens in these control files. So this is the directory, diode rectifier. Okay, let me expand it, and you see these are all the files, and here you see there is a file called __ control.py. This is a file the circuit simulator has created. We have not created this. This is our control file, switch __ control.py. This is what we created, but this is what the circuit simulator has created. So let me open this. Now you see what's happening. It has created a function called switch control func. Okay, so basically it has taken whatever is the name of this control file and added _func to it. So you can have 100 files and it will create 100 such functions with this underscore. So this function takes in a number of different variables. Okay, don't worry about these formatting. It's all internal. You don't have to worry. But what you have to think about is this. You see, we have created 3 inputs. Let's go back to that. See. Okay, we can actually stop it because we know what happens. And let's go back here, edit control, configure control. So we have created 3 variables, iSource1, vSource1, vout1. And let's look at this control file. You see, there are these 3 variables. And you see what's happening? These 3 variables are assigned to the output values of the components. You see what's happening? That's what's happening. So internally, don't worry about what's happening. Internally, these are actual cell positions and circuit sheet positions. But each of these, let's go here. Let's find out. 4J. What is 4J? This is sheet 0. Sheet 0 source. So let's look at 4J. This is 4 and this is J. This is voltmeter. So the output value, you see, dot op value, the output value of this voltmeter, which is this component, circuit component 4J0, 4J0, this is being assigned to V source 1. We have not done this. You see, our file is empty. We have done nothing. But this circuit simulator has now added this, has taken the output of the circuit component, that is the voltmeter, and has assigned it towards V source 1. And this is what it means by this statement. See, when I say add control input, you see, desired variable name and control code. We have specified the desired variable name and control code, and this simulator has taken the value of that meter and added it to whatever name we have specified. So this is how we access variables in the control code. So let's forget about this. Now there are some other things. You don't worry about this function. This variable is something totally different. I'll talk about it later. But this is how inputs are added to the function. Now let me just, for the sake of it, let me just add some function. Let me just say x is equal to 2. Let's say y is equal to x into 4. Just some dummy variable. This is just some dummy Python code which I am writing just for the sake of it. As you can see, it does nothing useful, but don't worry. What I'm going to do now, I'm going to go back and run this simulation with this new control code, and let's see what happens. Oh, okay. So I think you have to add something. So let's just add some variable. Save this, and then let's just delete it, because apparently you can't just go back. So anyway, add some dummy variable, delete. Back to control code and back to main page. Now let's go back to running this simulator. Now we made a minor change in the circuit simulator. Let me click on run. It's running. Let me just check once. There is no error. There is no error message. So it's running successfully. No problem. Let me go back again and let me stop this, because I don't really care. And now you see, this file has updated. These 3 lines are the same. These are our input variables. But you see what's happened after that? It has taken the control function, whatever is our control code. This is our control code for now. It could be later a PI controller, it could be a predictive controller, deadbeat controller, whatever you want. It has taken this and plugged it into this function. Alright? So in this way, you can actually write any amount of control code, and it is going to execute it all as a function. Okay, so this is how inputs are added to the circuit simulator. So at this point, I'm going to stop this lecture, and I will continue this lecture with the next part, and that is on static variables. The only reason I'm doing it is I don't want to have a very long lecture and then have problems actually uploading it on YouTube. So for now, let's just stop this lecture for now, and I'll be back. So thank you so much for watching, and continue watching with this, because there will be 4 or 5 parts to this video lecture series on control, and hope to see you soon. Thank you for watching, and bye, and see you soon again. Thank you.